Hello, welcome back to DTKSS. In this current session, we are going to discuss about Azure Service Bus. The Azure Service Bus is a fully managed enterprise message broker with message queues and topics with a publish and subscriber. So, using message broker, you can able to publish your messages through queues or topics. So, we'll discuss about how queues will work and how you can able to transmit your messages through topics using subscriber and publisher. And service bus is used to decouple the application and services from each other. So we'll talk in detail and what scenarios or what use cases we'll use the Azure Service Bus. For example, when you want to implement a messaging system, that is, when you want to transfer your business data such as sales or purchase orders or inventory movements. And when you want to decouple the application when you are transmitting the messages from one system to other system. So the main goal of decoupling the application is in order to improve the reliability and the scalability of application and the services. So how we can achieve that is producers and consumers don't have to be online or readily available at the same time. Meaning that the producer is available and the messages is producing, so they can push the messages to the queue or topics continuously. They no need to bother about whether the consumer is readily available to consume those messages or not. They no need to bother. Even they no need to care whether consumer systems is up or they're in down. They no need to bother. So even same applies to the consumers as well. So consumers will talk to the queues or topics under the service bus, and if there is any messages available under that queue or topics, they will read those messages and publish to the other machines. So using this service bus, we are achieving the decouple of applications. And one more scenario is when we want to implement the load balancing. That is, when you want to share a message in the queue to the multiple consumers. So what it was telling is allow for a multiple competing consumers to read from the queue at same time, each safely obtaining the exclusive ownership to the specific messages. So its message has published to the topic, and the same message can be consumed by the consumers with exclusive ownership to the specific messages and topics and the subscriptions. So using these topics and subscriptions, it will enable the one-to-one relationship. For example, if you are using any Netflix or anything, they will publish a content of video at their location, and it will publish to all the consumers who is watching those videos. It will publish to all the users, and it will be available whoever been added a subscription for that videos. They will able to watch that particular video multiple users. So we got from the Microsoft that enable one-to-one relationship between the publishers and subscribers, allowing the subscribers to select a particular message from the published message tree. So meaning that whatever the topics they are publishing with that in that topic, they no need to consume all the messages. They can specifically particular messages they can able to choose by the subscribers. So this is the scenarios you can use this service bus. Next, we talk about the key concepts of in the service bus. So when you want to create a queue or when you want to create a topic and create the subscriptions, first thing is you need to initiate the namespace. So what is a namespace? The namespace is a container for all messaging components, meaning that under the same namespace, you can create the multiple queues and multiple topics you can publish to the consumers. So that's what the namespace is, a container which can hold the multiple topics or multiple queues under the same namespace. So next we talk about these queues. So in the service bus, you can transmit your messages either two ways, using the queues or using the topics. So the queues will be used to store your messages, and it will deliver to the end users when they are ready to receive those items. But remember that in a queue, whatever the message is coming in first, it will be served first. So meaning that all the messages will be stored in order and timestamp basis, and it will deliver to the receiver also same order. So once the message broker accept the message, meaning that once the service bus accept the message from the center, this particular queue will store all those messages under the triple redundant storage, and it will spread across to the multiple zones. When you enable the geo redundancy for the service bus, whatever the messages you are pushing to the queue, it will spread across to the multiple zones, and the data backup will make sure if there is any disaster occurred in any one of the zone. So remember that in the queues, whatever the messages is pushed to the queues, it will not automatically notify to the end users, that is the receivers. Receivers must pull the request from the queue. It will not push to the receiver automatically. What it will do is it will just store all the messages, and receiver has to pull all the messages what it is there in the queue. So that is the how it will work the queue. So now we will see the demo how we can create the service bus and how we can create the namespace, and in that how we can create the queues, and also how we can consume or how we can send the messages or how we can receive the messages in the queue. So I'll switch to the Azure portal. Then here you can search the service bus. So you can select that service bus and click on the create button. So once you click on that, it will redirect to the create a namespace page. So you can select, so I'm creating one more resource group, D2KSS, and here I will name it as a D2KSS service bus namespace and pricing tier. So we'll browse this, what are the price tiers is available, and we'll talk about what is the difference between each pricing tier. Here in the basic, standard and premium. So what is the difference in these three pricing tiers is, in basic there is a shared capacity and a maximum size of the message is 256 KB, and it has only feature is queues. So how you can transmit when you are using a basic service bus pricing tier, you can use only queues to transmit your message from one system to other, and variable pricing. So it depends on how many messages you are sending, depend on that it will charge. And when you go to the standard, it is also having the shared capacity, and maximum size of the message is 256 KB, and it has the features is both queues and topics. So you can transmit your messages using the queue, or you can transmit your messages using the topics. The difference between the queues and topics is, in queues you can send to the one receiver only, so one to one. But in the topics, it will allows the one to n relationship. So depends on your requirement. You can choose either you want to transmit your messages through queues or you want to transmit your messages through topics. And then message operations. So this is the limit, and a premium dedicated capacity. So it will create a dedicated capacity, and the maximum size of the message is 100 MB. So here it is 256 KB and this is 100 MB, and it will allow the queues and topics, and it is a fixed price. So whatever you are sending the messages, 666 USD per month, and it allows the geo redundancy. So basically the premium is recommended for the production environment. So the recommended for the production workloads. So you can use basic or standard for pre-prod environments. For this demo, I'm going to choose queues. Since we are using the queues for this demo, I will choose the queues, and later I will update to the standard when we are talking about the topic. Right. So I will select this basics pricing tier and continue to the next steps. So networking, all I'll just keep all the default setting as it is. Once the validation is completed, click on the create button. So the deployment will take max 1 to 2 minutes. We'll wait for the deployment to be completed. Perfect. Now the deployment is successfully completed, and click on the go to resource button. So now you can able to see all these options is very common, and we have discussed in the app services what these options will help us to in the application. Now we talk about these shared access policies and then queues. So first I will go to the queues and I will create a queue. So I will name this as a D2K SS Q1. And I will just keep all the default setting as it is, like the maximum queue size is 1 GB and maximum delivery count 10, and the maximum time to live is 14 days, and I'll keep all the settings as it is and click on the create button. So once you click on the create button, the queue will be created. Perfect. Now the queue is created. So in that queue, you can able to see the maximum size. So all the settings. So this is the queue URL when you want to access the queue. And there is one more is shared access policies. So I will tell you that when you want to get the access for all the queues, you want to use only one shared token is you can use the namespace level. For example, you have created a one more queue, Q2, and click on the create button. Once you click on the create button, so now it will available two queues. So this is Q1 and Q2. So you want to access these both queues using one token is you can use the namespace level, that is the higher than the all the queues. So meaning that when you use the queue, the token under the namespaces is having access for both queues. Otherwise, if you want to use only this particular Q1 and you want to store the messages only this particular queue, means you can use that this shared access token. So either way you can use that. So for this demo, I'm going to use this namespace level. So the global level access token, which I can able to store all the messages into the both queues. So I'll open a Visual Studio. So now create a new project and create a console application. And give the name is Service Bus Q Demo, Q Center Demo. And I will call this as a Service Bus Demo. So this solution name is Service Bus Demo. Perfect. So What we have to do is click on the next button and click on the create button. So the default project template has been created. Now I will delete all the code which is generated by default. So in order to create a sender client or sender object, we have to install a new package called, I will open a console application, package console, and call this as a install package and copy it Azure Messaging Service Bus. Once the package is get installed, now create a using reference Azure messaging service bus. Then to speed up the process, I will copy the code and I will explain you what it is. So we are creating a service bus client and service bus center. So also we are creating the service bus client options. What is there in that client options is how we are transmitting our messages. So what it was meaning is the transmission, the transport type is AMQP. So this is a messaging protocol which used to transmit the messages from the producer to the service bus. Perfect. Now we want to create the object for this client and the center. So for that, to create the object, what is the values input parameters we need to pass for that service bus client and the service bus center is, we need to pass the service bus hub namespace connection string as well as in which queue you want to transmit your messages. So from where you can get these connection string values and the queue is, you can go back to the Azure portal and select the shared access policies under the namespace, not under the queue. So select the shared access policies. Under that you can find a root shared access token key. So this is having all the actions or all the clients to be processed. That is, using this key you can able to listen or you can able to send the messages. Either way, you can create one more also, like saying that sender key, and you can select only sender. So when you create this sender key, that means this particular, and you selected that only send, meaning that you can able to send the messages to service bus. Using this particular key, you cannot read them. And also you can create one more key, naming it as receiver key, and just put listen. So click on the create button. So what will happen is, if you want to use a specific key for the specific purpose like sending the messages or listening the messages, you can use these keys. When you want to use a key which can manage both listen and sender, you can use this master key. So I'm going to copy this particular root manage key, the primary connection string, and go back to the Visual Studio and copy that particular connection string. And you can also pass these options, whatever the options which you have been created, you can pass along with them. So what is this method is client options. Perfect. So you are, for the client, you are indicating that how you are going to communicate or how you are transmitting your messages using into the service bus. So you are indicating that you will transmit all your messages using the AMQP WebSockets. Perfect. So once you create the client, using that client object, you can create the sender. So to whom you want to send your message. So which queue. So go back to the Azure portal and click on the queues, and I will copy this particular queue D2KSS Q1 and I will replace here. Perfect. So now we have created a client object, we have created a sender object. Now what we have to do here is you want to create a batch object. Why we use this batch object is you have to add all your messages to this batch, and you are all the batch of the messages you are transmitting or you are sending to the service bus queue. So how we can create the object is, I'll use this code service bus message batch equal to that object name message batch. So this is the asynchronous method. That's the reason we are using await keyword. So what this message create message batch async will do is create the size of constraint batch to which service messages may be added using the service message batch try add message. So this is what we are going to perform next. Using this batch object, we are going to adding the list of the messages. You can add multiple messages to this batch, and all those messages is transmitting to the service bus at same time. So how you can able to do here is how you can add the messages to the message batch. Here I'm created a for loop. In that for loop, I'm checking a condition that I'm adding the messages to this message batch and checking that what this try add message method will help us is attempts to add the message to the batch. So meaning that all the messages, whatever the messages we are adding, it will add to the batch, and also it will ensure that the size of the batch does not exceed the maximum. So what are the messages we are adding? It does not exceed the maximum size. We already discussed that the maximum size of basics is 256 KB and standard also 256 KB, and for premium 100 MB. So using this try add message, it will ensure that it does not exceed the maximum. If it exceeds the maximum, it will throw this exception. What it was saying is the message is too large to fit to the batch. So whatever the message you are transmitting, it is too large, it cannot fit to that batch. Perfect. So until now what we did is we initiated the client object using the connection string. We created the center object. Using that we have created the batch. So this batch object will help to add the multiple messages. You can transmit the number of messages at same time to the service bus using this message batch. Then what we have to do, already add the messages, we need to send to the service bus. So I will add that particular code. So here what we are doing is we are sending the messages asynchronously to the service bus. At end what we are showing a console text is a batch messages has been published to the queue. Perfect. Finally we are disposing those objects which we created earlier, the client and sender object, we are disposing asynchronous. Perfect. Now what we have to do here is ensure that there is no build errors and run this application. So it has given a message is the batch message has been published to the queue. How you can confirm that whatever the messages you have been published to the queue is reached to the service bus or not. So in order to confirm that, go back to the Azure portal and go to that specific queue, and you can able to see, go back to here, one step back and go back to the queues. Here you can able to see that this particular queue D2KSSQ1 How many messages is there? 3 messages. How many active messages? 3. So how many we have transmitted is, we have run the loop in 3 times. That's the reason 3 messages has been published to the queue. Perfect. Now we have to see that what are all the messages we publish to the queue. We need to read those messages from the queue. So how we can read is, create one more console application, add the new project, console app, and name it as Service Bus Queue Receiver, and click on the next button and create the template. Perfect. So this is the default code has been generated. So now I'll execute one more time that receiver. Also I will execute the same NuGet package, that is Azure Messaging Service Bus. So the NuGet package is get added. So now we have to use that reference azure.messaging.service bus. So in order to speed up the process, I will copy the code one more time. So here, as same way, we have to create the service bus client and we have to create the service bus processor. So earlier when we are transmitting to the service bus, we have created sender. So now we have to create a processor. From there, you can able to, and same steps which we followed in our previous center also, we have to create our client options, which we are indicating is, we will read our messages using AMQP WebSockets. And now we have to create our, so now we have to create our client. So here we need to pass the connection string. So I'm going to get from our previous example that connection string, same connection string. Since it is having both listener and sender, so I'll copy that. And now we have to create the processor object. So copy that. So create the processor, for which queue we want to read is D2KSS Q1 and that service processor options. Perfect. So once we done that, so now what we have to do here is, we want to read the messages. We want to read the messages. So I will call this finally block. So for that, I'm going to create a processor dot process message async. So what this method will help is, the handler responsible for processing the message received from the queue or subscription. Implementation is mandatory. So I'm implementing the message. And one more method we want to implement here is processor and process error message. So what this method will help is, event will help is, the handler process error messaging. So is there any error occurred when we are processing or when we are reading the messages from queue and processing it? Perfect. So now we have to implement these methods. So first we implement this particular process message async method. So we have to args.message.body.toString. So whatever the message we are getting in the body, we are storing into a object called body. And then we are writing whatever the message we have received, we are writing into the console application. So received, so whatever we are receiving in the body, we are passing. And then we have to inform that org dot complete message async of dot org dot message. So what will happen when we say this, that complete message async, so that particular message will be deleted from the queue. When you execute this message, the complete message async, so this particular message what we have read already, that message will be deleted from the queue. So since this is a asynchronous method, we have to use a keyword is await. Perfect. So since we are using await keyword, we need to use the async. Right. So now we have to handle one more method is when there is an exception occurred, when we are reading a message from the queue, when exception occurred, we have to show the exception, what is the exception has been occurred, or dot exception dot toString. So we are showing that exception, and we have to return to the compiler that the task has been completed. Perfect. So we have implemented two methods. So first thing is implementing process async. Another one is process error async. So now what we have to do here is we want to initiate. So we want to start reading the messages from the queue. So processor dot start processing async. So since it is a asynchronous method, we will call this as a await keyword. And here we have to write a console text is some console text to indicate whether the process is started or not. Wait for a minute, then press a key to end the processing. And once it is done, we have to stop the processing as well. So stopping the receiver, when you click on the read key, it will stop the processing. So this particular method will be get executed, and it will show the text is stopped receiving the messages. Perfect. So I'll just repeat again what we have done now. So we have created a client and processors using the connection string, and the processor using the particular queue, which queue we want to read that messages. And then we have implemented how we have to read those messages and how we have to display that messages into the console applications. Then we have to start and stop the reading the messages. So first build the application, ensuring that there is no build errors. Perfect. So make it this as a startup project and run this. So the process has been started. So we'll wait. So messages has started reading that. So all the messages has read it. So we have published only 3 messages. All the messages has been read, and it is waiting. This particular program is waiting to read the messages. So in order to stop this program, press enter. So it will execute that particular statement, this stop processing async method, and it will stop the process. So this is the about how you can create a queue in the service bus, and how you are pushing the messages into the queue using the C# console application, and how you can read the messages continue asynchronously using this console application. Thank you.